So I have wage equal to beta 0. Right, and then plus a dummy variable represent the channel or wage. So I got here, right? This is 0, female. Right, and then also plus here, beta 1, education, and then plus an unobserved variable. Okay, so I've got that new variable here, right? Female. This female here is a dummy variable. It's a dummy variable because it got only two values, 0 and 1. So if I put in the female here, right? I'm gonna put it 1, that's a female. Right, and 0, that's female. Okay, so this is called a dummy variable. The dummy variable here got only two values, 0 and 1. 0 and 1. So I put female here, right? So I put here 1 is female and 0 here is male. So this is an struct here in the data. So here, right, we got here the wage, right? This is number of observation, and the wage, education, experience, and then I got a new variable here, right? So this variable here is called female. And then the value 1 here, so we know that the first person is a female. Right, so the first person here is a female, and then the third person is a male. Similarly here, right, I can put here a merit, so to see whether their marital status. Okay, so the merit variable is also a dummy variable, showing people's marital status. So 1 here is merit, right? Merit person, and then 0 here is unmarried. So if you look at the first person here, right, we can read, she's a male and unmarried, right? One is female, she's a female and unmarried. Number 2, right, she's a female and married. Number 3, he's a man and unmarried. And then number 4, he's a man and married. Okay, so that's called the dummy variable. And once you put the dummy variable here, right, and again you're gonna run a regression. Just like normal, right, as you run the multiple regression, and then you can have this, for example, result. Then you can have a result here. Okay, so how can we interpret the result? If you look at this, right, okay, so if you look at that over there, and if you see here, right, female is a negative number, and if you got the T statistic, so this is needed, and then we say, okay, female here, right, female, and then this is male. So if female is equal to 1, this is equal to 1, right? And then you're going to have the slope of the line going to be equal, right? So you're going to have equal here. Okay, so now if we got here female, right, and we can write this formula as wage equal to beta 0, right, plus lambda 0, right, and then plus beta 1 education, right, plus the unobserved variable, right. So that's the case of female. In the case of male, right, so you can write this as wage equal to beta 0 plus beta 1, right, and education plus the unobserved variable. Is that right? Because here, right, in the case of female, so this variable is 1. 1, so you got beta 0 plus lambda 0 here. Okay? And in the case of male, so this is 0. And you got only beta 0s here. So if you compare these two, right, female and male here, this is different, right? We got here different in the intercept. The slope is the same, right? So below 1 is the same. So if you draw the equations here, for example, on this, the vertical one, you got wage. So here you got wage. You got the wage here, right? And here you got allocations. So the slope here is, they are both beta 1, right? The slope here is, they are both beta 1. And then this is beta 0. And that's it corresponds to male, right? And this is beta 0 plus lambda 1 for example. Okay? So the difference here, they are difference in slope. The difference in slope. So this is slope for female and this is slope for male. The beta 1 here is the same. It's the same. So if lambda 0 here is negative, okay, so if lambda 0 is negative, and you can see here, right, the wage of female will be smaller than the wage of male. For the same level of education, so here, right, for the same level of education here, the same level of education, and if we got here, lambda 0 here is negative, so the slope of female, the intercept of female will be lower than the intercept of male. Okay, so we got this here, right? Okay, so this is, I say, beta 0, right? So that's the case of male, right? So if we got here lambda 0 is negative, so you got here, right? This is beta 0 plus lambda 0, right? Because this is negative, right? This is smaller. So for the same level of education is the same. And you put it down up here, right? So this is female salary. Right, so this is female, right? And this is the male salary, right? So female salary will be lower than male salary, given everything constant. Alright? So by looking at that here, right, we're going to be able to interpret the information here. So if we look at this, right, we can say, okay, holding other thing constant. So holding education, experience to be constant, for example. And then on average, female salary here, right, lower by $1.81 than the salary of male. Okay, so by looking at that, right, we can see the difference here. Here in this case, we got here the base case. So this is the base case. This is the base case. Because this is the base case, and this is the female scale, right? So compared to the base case, the salaries of female here is smaller than $1.81. Okay, so that's the median of variable. The median variable. So if you compare to the case that variable equals 0, right? And that's in the base case. The base case, and we say, okay, the female salary here is lower by $1.81. And here in this example, wage here, right? We made this in absolute number here. In absolute number. Also, we have something, for example, like this. Okay, so I can have here, right? Okay, so I have this one, the serial one, right? And in this case, you got here the log of wage. So everything is, you see, you should look at this term over here, right? Already look at this term. So this is the log of wage. And then you got here female here, right? Is minus 0.227. So how we interpret this? We just look at female. We're gonna explain the meaning of this later on, right? We just look at this. So here we got log of wage, and here we got female. Here, right, I got wage only. Right, so if we say here, right, in the previous example, and here, right, so we got wage here, you look at female, and just see minus 1.81. And we say that compared to the man's salary, holding everything constant, for the same education, the same experience, the same tenure, and so on. So female salary on average is lower than $1.81. Okay, so that's in absolute terms. instead of wage, we have something called the log of wage. So for example, like this, right? We should look at this, we don't ignore these things, we're going to talk about this thing later. So we should look at the log of wage and look at that. So how we interpret this number? Remember log of wage, log of I instead of I? Yeah, percent. So we're going to say, okay, compared to men, right, the female salary is lower by 23%. Okay, sorry, it's 22.7%. In terms of percent, right? So 22.7%. So you're going to compare in terms of percentage, rather than absolute number. So that's the first thing, right? The dummy variable. So in dummy variable here, right? The dummy variable. And the dummy variable in this term here, right, we're going to change here the intercept. You change the intercept. Okay, so is that clear? Okay, and now we can extend this problem here a little bit more. So we're going to look at this case, for example. This case. Okay, so what is the problem of this? Why here in this example, we only include female, but we do not include male here? Yes, here right, we got the problem perfect collinearity. In our assumption, right, in assumption 2, and we say, okay, in order to run the regression, and we should have no perfect collinearity. So basically, if we got a male, right, and female, right, and they all sum up to 1. So basically, female equal to 1 minus male. Right? Yeah. Okay, so in that case, remember this is a rule. If you got here, right, a gender, right, and gender here, right, got only, okay, like they got gender 2 female or male. So in the dummy variable, you're gonna put only 1 variable in. Okay, so here at the rule here. So if I got gender, right? So in gender here, I got female and I got male, right? And when I prepare the dummy variable, and then I got only 1 variable in, so I can put female in, or I can put male in, but not 2. Okay, so I even put female in, and the value 1 here is female and 0 going to be the base case, which is male. If I put male in, right, so I'm going to get male equal to the value of 1, and the base case is going to be woman, female, the value of 0. So now assume, right, if I got, okay, I want to see whether there are any difference among the quarter sales. So I collect information related to sales of company, right? And I want to see whether there are any difference among those quarter sales. So I got here the sale in the first quarter, in the second quarter, in the third quarter, and in the fourth quarter. So how I incorporate that information in the dummy variable? Okay, so I got another example here, right? I want to compare sales among 4 quarters. Okay, I want to see whether the sales in the first quarter or in the second or the third quarter got any different. So I have here quarter 1, quarter 2, quarter 3, and quarter 4, for example. They have 4 quarters here. Now, if I incorporate this information in, right, I'm going to have two ways to do it. The first one, I can put a variable for quarter in. Right? And this variable here, you're going to receive the value 1, 2, 3, 4. Right? On the second one here, I'm going to use dummy variable. Okay, so I said again, right? Assume that I want to see the difference, other difference among sales in different quarters. So I may expect, for example, like for this company, sales in the fourth quarter may be higher than sales in other quarters. For example, you got seasonality. Some firms, right, if you don't have sales and they got seasonality, And then we expect that firms at the end of the year, their sales will be highest, for example. So I expect that maybe quarter 4 going to be the highest sales. Okay? So now I'm going to incorporate that quality information here in my equation. So the question is, how am I going to do that? So I think, okay, at the first part, right, I think I may put a number, a variable per quarter, right? I create a new variable per quarter, and I put number 1 for quarter 1, number 2 for quarter 2, number 3 for quarter 3, and number 4 for quarter 4. Can I do that? Ở đây là tôi nói là giả sử như tôi tạo ra một cái biến của tôi có tên là quarter. Và sau đấy thì tôi thấy là đây là sale của quý 1 thì tôi ghi quarter, đấy là tôi để số 1, đúng không? Đấy là cái này là sale của quý 2, đúng không? Tôi collect sale của quý 2 thì tôi để cái quarter đấy là số 2. Tôi collect sale của quý 3 thì tôi để cái quarter đấy là số 3. Mình làm như vậy có được không? Nếu như làm như vậy thì có vấn đề gì xảy ra? Đúng không? Ví dụ như là các quý của chúng ta, giả sử như chúng ta bán là quý 2 lớn nhiều hơn quý 3, quý 4 nhiều hơn quý 3 chẳng hạn đấy. Thế là chúng ta bán là quý 1 là thấp nhất, quý 4 là cao nhất, đúng không? Thì lúc bây giờ chúng ta chạy chương trình chúng ta nói quý càng cao thì sale càng lớn. Nhưng cũng có những trường hợp ví dụ mình bán sale được rất là nhiều ở quý 2 và quý 3, đúng không? Đúng không? Thì lúc bây giờ quý 1 và quý 4 là thấp, đúng không? Và khi mình để cái biến quý như vậy thì nó sẽ không có ý nghĩa gì cả. Đúng như là cái sale của mình nhiều ở quý 2 và quý 3, đúng không? Thì quý 2, quý 3 thì nó lớn hơn quý 1, nhưng mà quý 4 vẫn lớn hơn quý 3, đúng không? Đúng không? Ở trong trường hợp đấy thì nếu mà để một cái biến qua đời đi 1, 2, 3, 4 như vậy thì nó không có ý nghĩa gì hết. Đúng không? Trở lại mình nói là quý càng cao, tức là quý ở đây là đôi về thời gian hay là cái số lượng, đúng không? Quý chỉ là 3 tháng đầu thì gọi là quý 1, 3 tháng rưỡi thì gọi là quý 2, đúng không? Cho nên là mình sẽ không làm như vậy. Thế chứ còn mình, thế thì đấy là một cái ví dụ. Cho nên là cái cách đấy thì bây giờ mình sẽ chuyển qua là làm dummy. Thì nếu làm dummy thì mình sẽ tạo ra các biến như thế nào? So we're going to create 3 variables. Yes, 3 variables, 3 dummy variables, and dummy variable got the value 0 and 1. 3, okay? So I'm going to create 3 variables. Okay, so if sales is in quarter 1, so I'm gonna get 1 if sales in quarter 1 and 0 if sales in other quarter. Okay, so the quarter 1 here got value 1 if the sales in the first quarter and 0 for other quarter. And then quarter 2, 1 and 0. So if you see quarter 2 here got the value 1 here, they're going to be sales in the second quarter and 0 for others. And then quarter 3, this is 1 and 0. Do we need quarter 4?
No.
No, right? Because if the first 3 here got the value equal to 0, that should be in quarter 4, right? Because here, right, 0, so it's not in quarter 1. 0 is not in quarter 2, 0 is not in quarter 3. So it's not in quarter 0, in quarter 1, in quarter 2, in quarter 3, it must be in quarter 4, right? Okay, if you create a new variable for quarter 4, you're going to have a problem of perfect collinearity. Okay, because here, right, you can say, okay, 1 minus quarter 4 equal quarter 1 plus 2 equal quarter 2. Okay, so in order to create dummy variable, in order to avoid the problem of perfect collinearity, right? And then you should only choose n minus 1 dummy variable if you got n categories. Okay, if you got n categories, choose only n minus 1 dummy variable. So here, right, I got 2 genders, right? Female and male. So 2 genders. I only create 1 dummy variable. Here I got 4 quarters, so I got 4 categories. I only create 3 dummy variables. Okay, so n minus 1 dummy variable. Okay, so this is one example. Now look at another example. So instead of quarter, okay, and then I gonna have an example, another example here. I'm looking at credit rating. I don't know what to think about that. Yeah. Okay, here, right? So we got information here, right? City credit rating and municipal bond interest rate. You know that, okay? Here, right? So the credit rating here, for example, it ranges from 0 to 4. Higher credit rating means lower risk. Lower risk will have lower interest rate. We want to see the relationship between the rating of the city and the bond issued by that city. So municipal bond, right? Municipal bond, they are bonds issued by the local governments. Okay, they're bond issued by the local governments. So we want to see the relationship between the municipal interest rate and their credit rating. And higher credit rating means lower risk. Lower risk means lower required rate of return from investor and lower interest rate. Lower interest rate. And then the credit rating here, right? Got the rate here from 0 to 4. Okay, so 0 will be the worst and 4 will be the best. Okay, so again here, just as water, I'm going to have 2 ways here, right? The first way, I'm going to create a variable called credit rating. So CR stands for credit rating. And CR here is going to have the value from 0 to 4. So 0 worst, 1 medium, and then you got 4 the best credit rating. Or another one, right? I'm going to create that, okay, 4 dummy variables. Because we got 5 categories, right? From 0 to 4, so 5. So we're going to create here, okay, 4 dummy variables. 4 dummy variables. Okay, so which way is going to be better? Here in this example, right, I say, if I create the variable called quarter, and quarter, we're going to write quarter, right? Quarter 1, quarter 2, quarter 3 is just time, and with primary is really kind of right. So that's another good way. How about this? Can we create a variable called credit rating and got the value from 0 to 4? And basically, we can write that right 4 higher than 3. So what's the problem of that? Lúc nãy mình tạo cái biến là tôi nói là mình có 4 quý đúng không? Và mình không nên tạo một cái biến có chữ là quý, xong rồi để số 1 là quý 1, số 2 là quý 2. Bởi vì lúc mà giả sử đưa ra kết quả ấy, là cái quý 2 và quý 3 của mình sale nó nhiều hơn quý 1 và quý 4 thì cái biến này sẽ không bao giờ chịu đấy. Đúng không? Đúng đấy, tại vì là quý càng cao thì sale càng nhiều, hoặc là quý càng ít thì sale càng nhiều. Đây là quý 2, quý 3 là những quý ở giữa đúng không? Cái số ở giữa đó là nhiều hơn 1 và 4 thì chúng ta sẽ không có kết quả. Đúng không? Cho nên là đối với cái quý thì chúng ta sẽ không lập một cái biến tên là quý để đặt tên là 2 và 4. Nhưng mà bây giờ chúng ta lại có một cái biến gọi là credit rating. Credit rating ở đây là từ 0 đến 4. Hoặc là một số chỗ ví dụ Morningstar rating thì nó từ 1 đến 5. Và đây thì 1 thì nhỏ hơn 2, 2 thì nhỏ hơn 3. Tức là càng cao thì credit rating của nó càng cao. Thì trong trường hợp như vậy, các bạn thì nếu mình đặt như vậy thì có vấn đề gì không? Có vấn đề gì đây? Sao? Đúng rồi. Thế thì khi, phải nói thế thì sao được không? Khi mà cái biến của mình là quantitative, đúng không? Thì ví dụ như là education là 1 năm, 2 năm, 3 năm, 4 năm, thì khoảng cách giữa 1 và 2 là 1 năm. Đúng không? Education là 1 năm, education là 2 năm, thì khoảng cách giữa 2 và 1 là 1 năm, đúng không? Khoảng cách giữa 13 và 12 là 1 năm. Tức là giữa những cái khoảng cách đấy là đều nhau, đúng không? Đúng chưa ạ? Thế còn nếu cái credit rating ấy, thì credit rating ấy người ta assign cho nó là cái số như vậy thôi. Chúng ta biết là số 4 thì nó tốt hơn là số 3. Nhưng mà cái khoảng cách giữa 4 với 3 và giữa 1 với 2
cái này
nó không bằng
đều.
Đúng chưa? Bởi vì đấy thì là cái số hiệu người ta assign cho nó là như vậy. Là như vậy. Cho nên là trong trường hợp như vậy thì các bạn cũng không nên đặt một cái biến là credit rating xếp từ 0 đến 4. Mặc dù là về thứ tự thì là 0 nhỏ hơn 4 đó. Đúng không? Nhưng khoảng cách giữa những cái biến này nó có thể không bằng nhau. Đúng không? Từ 1 đến 2 thì chắc là từ 3 đến 1. Okay. Okay. So in this case, the better way here, right? We're gonna use here dummy variable. Dummy variable. So now I'm gonna have another sample here, right? I have this example here, right? I have sales. So I have here, right, sales, right, equal to 0.5 or something, plus 0.7, here part of 1 minus 0.8, part of 2, plus 0.9, part of 3, and then plus. Okay, and sales here is measured in terms of say $1 million. Okay, so again, right, I run the regression of sales, right, on the dummy variables here, which is quarter. Okay, and then we got other variables here, right? So the result here appears to be, okay, sales in terms of $1 million, we got 0.5 plus 0.7 part of 1, and then this is it. So how can you interpret the meaning of that 0.7? Yeah, holding other thing constant. Sorry, can you louder, please? No, I mean, we run the regression, right? We put that data into the software and we got the formula, the regression result there. So, for example, right, in beta 1 for Q1, the result is 0.7. So, how do you read the 0.7? Okay, and then hurry constant, and then so you get the trend, right? But what is the meaning of 0.7? Yeah. Higher than the sale in the other quarter? In the average? Okay, so here, right? When we interpret, we're going to interpret here, right, the value of that meter compared to the base case. Chúng ta so ở đây ấy, bởi vì là chúng ta cái 0.7 này có nghĩa là quý 3 và quý 4 là constant rồi. Như vậy chúng ta cái quý 1 này là so với cái quý mấy các bạn? Quý 4. Quý 4. Các bạn sẽ so với cái base case là quý 4. Và như vậy là chúng ta nói là quý 1 doanh thu là cao hơn 0.7 triệu đô so với quý 4. Yeah. Chúng ta so với cái base case chúng ta là quý 4. Quý 2 là nhỏ hơn 0.8 so với quý 4. Quý 3 là lớn hơn 0.9 bình quân so với quý 4. Đúng không? Thế thì đấy là cái cách mà các bạn được đọc ở đây. Tức là mình so ở đây là 0.7, 0.8, 0.9, đấy là so với cái base case. Cái base case của chúng ta là tất cả những cái đó bằng 0, đúng không? Đúng không? Tất cả những cái đó bằng 0 có nghĩa là đấy là quý 4. Đấy là quý 4. Okay? So here, this is one case, right? So this is the wage of female is smaller or higher than the male's wage by that amount. Okay, so now we've got more like Q1, Q2, Q3, for example. So when I interpret here, right, the value of the sales in Q1 will be higher by $0.7 million compared to the quarter cells, the quarter 4 cells. Okay, so we got here the base case, and the base case here going to be the case at which we got the value 0 here, right? 0, 0, 0, so that is the base case here. The base case here will be the variable that we will not include here in the formula. So if you look at here, right? So the base case is going to have the credit rating equal to 0. That's the worst case, right? The worst case. So if you got here, right, credit rating 1, and then your misbond rate, for example, will be higher, lower than you got the credit rating 0, right? Like that amount. Okay, so that's how you interpret the formula here. The formula. Okay, so this is slope, and then we mark here, right? Okay, so again, remember, when we use W variable, right? When we use W variable, include only 1. Right, so if you got 2 gender, include only 1. If you got 4 quarter, okay, you got only 3 W variables. If you got 12 months, right, you only include 11 months W variable. And then if you got, for example, you want to see the effect of industry, and so if you got 10 industry, right, include only 9 W variables. 9 W variable. And if you interpret, right, you're going to say the sales in industry 1 will be higher than industry 0, which is the base case. Okay, so that one here, right. We can only include 2 here if we omit the intersect. So you've got minus 0, and we include it here, right? This is very different. So this is not the good way to do it. Only 1, either female or male here, right? If you got female here, the base case are man. If you got male here, the base case are women. Okay? So you got a flat, hold it constant, and then you got the interpret rate. The female salary is lower. There by minus 1.81. Holding these constant. Holding these constant. Okay. Okay, so similarly, right, you may want to study another sample. For example, you want to see the effect of training grams on hour of training. Okay, so we got 2 groups. The treatment group here, right, is the ground receiver, and the other one here is the control group. Okay, so sometimes you got here, right, you got the treatment group, you got here 2 different groups. One group that have vaccination, and the other group got no vaccination.